Welcome everyone to SGX3's monthly webinar series. My name is Janae Baker. I am our community project manager. And for this month, we are thrilled to have Charlie Catlett join us for our talk on opportunities for accelerating progress through international collaborations. And a little bit about Charlie. He is a senior computer scientist at Argonne National Laboratory and founding executive director of the Trillion Parameter Consortium, a global community accelerating AI for scientific discovery. His research focuses on AI integrated with high performance computing, wireless networks, and intelligent sensing in urban and environmental settings. He previously served as CTO at the National Center for Supercomputing Applications and holds a computer engineering degree from the University of Illinois at Urbana-Champaign. So welcome, Charlie. I will hand it over to you.
Thank you, Janae. I'll go ahead and share my screen here. Okay, so I want to kind of cover three things here. One is the big picture of AI for science, and at least from the perspective of the Department of Energy at DOE Labs, and where we've sort of come over the last 8 years or so, and where we are today and where we're going. I'll talk in the middle a little bit about some of my own research that I'm doing with teams of people locally at Argonne, but also as part of the SAGE project, or SAGE Grande Testbed project, which is a NAIR pilot effort that's led by Northwestern University, Pete Beckman, and as people from UC San Diego and SDSC involved as well. And then I'll talk about the Trillion Parameter Consortium and opportunities that there are to work through that community to find collaborators and to support international collaborations. So I'll just go back in time. I began working with high performance computing in the mid 1980s, but I wanted to mention that AI has been an HPC application at least for the last 35 years or 30 years or so. There was a weekend in 1994 when at NCSA we turned over our CM5 to a team from MIT, including a graduate student at the time, Chris Jorg, so that they could use the machine to play a chess match as part of this international computer chess championship. Then we caught some flack from the rest of the science community, but we pointed out, look, this is, yes, it's chess, it's a game, but it's also science and the science of AI as it stood at the time 30 years ago. Fast forward to 2018, if you listen to the talks that Jeffrey Hinton or Jan LeCun gave, one of the things that stood out to me anyway as an HPC person was this statement by Jeffrey Hinton that really what happened with this explosion of AI capability in the last 8 or 9 or 10 years has been high performance computing. We finally have the machines that are large enough to do the training necessary to reach this threshold of capability that we've all come to almost take for granted. If I go back to 2019, we were a couple of years into trying to determine how we would use, at the time we're talking about deep learning and machine learning, less about AI. We just talked about machine learning, deep learning, how we would use those technologies to advance science from this point of view of Department of Energy laboratories. And in 2019, we had a series of workshops and then another series in 2022 because so much had changed in between. And of course, we were recovering momentum in this area, having been separated by the pandemic. And if you look at the two reports that we did in 2019 and then the next year, the report came out, we had this, I would say, kind of early, not necessarily naive, but an early view of how we might use AI. And we were just thinking of AI as a thing, as a maybe a little bit more sophisticated than just saying, what could we do with neural networks or deep learning? And so our report reflects this. There's not much nuance about AI. It's more all of these different disciplines that you see on the screen, and each of them saying, well, how would I use AI? Then when we came back together in 2022, and then the report came out in 23, we had a much better idea of the transformative nature of AI in that there were ways that we could use AI for specific scientific challenges. And at the time, the famous opportunities and risks of foundation model paper came out, there were already, I would say, some of the early use of HPC using AI, where the surrogate models, an AI model that's trained with the output of a physics-based model and can do at least an approximation of that physics-based model, sometimes thousands of times faster. So the report in 23 was organized, we still organized around disciplines, but we had this better idea that there were areas that we could improve and build on that would lift all boats. So if we built capabilities in terms of surrogate model training and workflow, that would help people in multiple disciplines. Similarly with robotics and autonomy or inverse design or even more universal programming and software engineering. So that report then we had a much better idea of how we might use AI in specific ways. And today, so that's 2023. Today, really going back to the announcement of the Genesis mission back in late 2025, we are all of the DOE labs and soon many more universities are involved in something called the Genesis mission, which is an attempt to take all of our data and computing and methodology and create a platform that allows people to use AI for their science as just a day-to-day, the same way we use the internet today. We don't really think about I'll use the internet or I won't use the internet. We just do. And so we want to, in this project or this mission program, build a nationwide platform that takes our capabilities, instruments, computers, data, expertise, and brings them together in such a way that people can embed AI in their science. And the goal is to at least double scientific productivity, if not go further than that. So far, this effort has been DOE laboratories. As we've been trying to get off the ground, there were two large consortia that were funded and started up last October. One called the Transformative Models Consortium, which Argonne leads and includes at least 8 DOE laboratories, including Oak Ridge and PNNL and others, Berkeley. And then the American Science Cloud, you think of the model consortium as the AI capabilities and the connection to model teams, disciplinary teams. American Science Cloud beneath that, across some APIs, the infrastructure that we need to do this. Now, this slide here shows many different sectors, government partners, industry, academia. We started with DOE laboratories. Now industry has been involved in the last month or so. We're working out how they can be involved in the mission. And then an announcement went out just in the last week for a $300 million program that is aimed at not just DOE labs, but includes industry and academia. So before I talk about that call, I'll say I mentioned the American Science Cloud and the Model Consortium, or ModCon we call it. And one way to think about this American Science Cloud and the Model Consortium is there are these model teams, which are disciplinary teams trying to apply AI to their scientific area. They have all sorts of data sources from computational model output to time series from sensor networks or experimental output data. And there's a need to transform that data into something that is fair and AI ready. So it's ready to be used, AI ready, ready to be used to train models. The Model Consortium, if you can look at the sort of right-hand side there, we have 4 teams within the Model Consortium. I'm just going to expand one of them here, which is the base cross-cutting capabilities team. And there you have 6 different efforts led by scientists from around the DOE laboratories who are building everything from multimodal training capabilities to agentic systems, data prep. A big one is the evaluation of reasoning and scientific skills of models. And so all of these teams are working together to apply those capabilities to these work of these model teams. And so I mentioned this RFI that came out, 9 days ago, March 17th. And this RFA, it's got some deadlines. The first one is late April, and the last one is mid to late May for submission of applications to this program for grants that range from 750,000 to multiple million. And the areas of interest you can see on the right-hand side, these 21 areas, each of which has focus areas beneath them. You can see these are a mix of disciplinary science and AI and computer science across these 21 areas. This report, you could just Google Genesis Mission DOE, and you can get this, I don't know, 700 page. It's a very long document, and it describes the program. Okay, so that's what's happening with the Genesis mission. I said I want to talk about three things. The second thing I want to talk about, but maybe I'll pause here in case anyone has any questions about Genesis mission before we move on. And I'm not sure if I can see or how I can see the chat screen. So if you have a question, just go ahead and speak out because I can't see the chat. And if you don't, then I'll keep going. So let me switch from the big picture of Genesis Mission and DOE to some of the ways that we've been using AI in a project that originally was called Array of Things and is now the Sage Grande testbed, where what we started out doing was in about 2013, 2014, in our design of these edge systems, we said we've got to have a capability to do AI in situ at the edge because we're never going to have network capability to wherever we want with the bandwidth that we need. And there are benefits to doing AI at the edge as well, including very strong privacy capabilities that you can build into systems, which was an important area for us at the time because we started out with the project to build these edge systems and put them in the city of Chicago and other cities. And over time, what I want to also show is the project today has gone through a sort of prototyping 10 years ago, and then 6 years ago went into let's now make this prototype into a scalable platform that people can program to and deploy. And to what we're doing now, which is using MCP to try to allow a natural language interface to, at least at the current time, to interrogate the system of devices and bring data out, but eventually to design and deploy experiments using the infrastructure. So we started AI at the edge, and then we've moved sort of forward into agentic AI over time. Now, as I mentioned, the first grant that we got for the Array of Things project was 2015. And you can see here this vision on the upper left that we would have cameras and edge processing units and a microphone and other sensors, and that we would do the seeing and hearing, if you will, out at the device. These devices are, I don't know, the size of a backpack. And then we would transmit the process data. So if we have an image, rather than transfer video back to some data center, we would analyze the image and pull the information out that we needed, the number of electric vehicles, the number of pedestrians, the amount of noise or types of noise, and then send that back to the central data system. And you see here a number of projects over time, and I guess it's probably close to 300 locations in Chicago by now where we have today or have in the past devices. The blue dots that you can see there, about 130 array of thing nodes, those are now retired, as are the red triangles, which was a project that we did with Microsoft Research. These were small battery and solar powered devices, not much computing at the edge there. And then the SAGE project, which began in 2019 and continues today in its second iteration of grants, are those yellow diamonds that you see there. I think there are maybe 24 by now. This slide might be a little bit out of date. And where we're going today is, as I mentioned, to try to put natural language capabilities in between the scientists that want it in between. There, you can bypass it, but a natural language interface to measurement infrastructure. So all of these devices have a variety of capabilities. The original Sage devices and array of things nodes that you see there had these, you can read the list of sensors on them. There were only, let's see, four sensors on the Microsoft device at the bottom right. But you can see the kind of deployments that we did in the city were typically 28 feet above the sidewalk, pointed down. We had very strong, still do have strong privacy policies that govern what can be done with those images, and of course limit the number of images that are persistent because we're saving the training images periodically, but for the most part, the images are either analyzed or they expire and go away. An example of a project using the cameras is the one in the middle there at the bottom with those red and blue lines. And that's an experiment that Mike Papka and his team did at Northern Illinois University, just looking at a particular intersection from a safety point of view. How many people are using the crosswalk? Do we need to put a signal light there or some crosswalk safety thing? And so each of those lines, a blue line is somebody walking away from the camera. A red line is somebody walking toward the camera. And an example of a way you can look at pedestrian flow and other things without getting into surveillance or other privacy concerns. The idea of the capability of AI at the edge is something that we then started 10 years ago or so to say, well, what we're really doing is analogous to software-defined radio, which is you have a computing device with a very flexible antenna capability, and you can tell it with software what's the framing, what's the bandwidth, what's the frequency that you're using, and decide now it's a cellular phone and the next it's a FM radio, all by changing the software. So the notion of a software-defined radio influenced us to think about a software-defined sensor where we have a camera, but it's in some cases a wildlife sensor. In other cases, it's a wildfire smoke detector. And that is purely based on the model and the software that we push out to that node or to that set of nodes. And so here is the sort of complicated architecture now where we have put large language models at various places, including at the edge and in HPC systems, with a user that can either go in as an expert or can go in through text prompts. And I want to give you just an example of that, where what we did a few months ago is our team put together an MCP server that sits between whatever vibe coding system or model you're using and the Sage infrastructure, because there is a portal you can go to and you can interrogate the nodes and get maps and filter the nodes by capability or location. But this is a way for you to do that without knowing anything about the infrastructure, just to interact with the MCP server. So just a few screenshots here. Back in January, I'm like, well, our team has been doing this, but I've never actually tried it out. So I had the advantage of getting their help as far as where I should find the configuration information. I'm using Warp here as the vibe coding engine. And so I put the MCP information in there. I had my account enabled to use it. And then I just started asking questions like, I was giving a talk in Seoul, Korea. Where are the closest three nodes to Seoul, Korea? And you can see it. The closest ones are these three that are in Hawaii. So I went a little further and I said, well, are there any images in the last hour or so? And it turned out one of them was up and running. The other two had suffered recent power outages due to some electrical storm or something like that, which was a little bit unfortunate. But I went further and I said, okay, well, how about just show me an image, the latest one from the node in Lahaina in Maui, and I'd like to see the sky-facing camera. And in the course of like 2 minutes, I think I started at maybe 10 till 2 p.m. and this is 10 after 2, starting from scratch. And now I've got a sort of live or recent image from that sky-facing camera. And had I been using this back in December, I might have said, hey, I heard there's a volcano erupting on December, let's see, it was December 6th. And so show me the latest images from that. And you can see there are two imagers at that particular node. One on the left is visual, and the one on right is infrared. So this notion of dropping the barrier for scientists to be able to use this infrastructure, and maybe a scientist would just want to pull this video, maybe they would want to pull an image, or maybe they would want to pull the um, data from other sensors like temperature, humidity, or PM 2.5 or what have you. And then just for fun, I'm like, okay, well, this was in January. I said 5 minutes later, I said, show me the latest downward facing camera at Jackson and State in downtown Chicago, which is a particularly interesting intersection because as you can kind of see, it's a little bit masked by the salt on the streets from the winter time, but this is a scramble crosswalk. So it's a place where we can have transportation research people can study the flow of pedestrians by using this device. Okay, so kind of a quick switch to more recent work in the last month or so. Some of us have been looking at, of course, we've been looking at agentic systems for quite some time now, but it seems that OpenClaw is all the rave. About a month ago, I decided to try to run OpenClaw on I have a DGX Spark that's sitting right next to me here. So it's a reasonably good inference machine, and I'm running a Quen model on it that is powering, at the moment, three OpenClaw agents. One that's not shown is just managing my Gmail, which is clogged up with junk. And so I've got it watching for people that I are in my contacts list and sending email to my work email with a summary every day of what happened there. The two agents here are, I'm going to say this is not really a scientific application, but it was an application that I was interested in to learn the capabilities and understand the gaps of OpenClaw as a platform. And so you have here these two agents that are aimed at helping us manage what will be a 500 to 700 person conference that's happening, as I'll talk about in a moment, called TPC 26. And for that, there's several processes. I'm illustrating one of them here. There's one agent that sits between a Google form that will probably get 200 to 250 submissions in the next few months, and a bunch of people on the right-hand side who are responsible for organizing parallel tracks. There's 8 of those, and some of them are responsible for organizing tutorials. So you can go to this Google form and say, I want to give a talk. Here's my title. Here's my abstract. Here's who I am. Here's my co-authors. And I choose from 8 different tracks. And then do I also want to submit this talk as a possible lecture as part of one of the AI for Science tutorials? And so the 4 at the bottom. So in order to make it easy for these blue people on the right to do their job of orchestrating all of these talks, there's an agent that simply looks at this forum every day, puts together a report into Slack for these folks to look at. And if there was a new submission, let's say to the orange track, then the person responsible for that would get an email message that says, "Hey, new submission. Here's a link to the talk and to the general forum in case you want more information." Then there's a second agent that sits there and knows everything about all the talks, the program, etc., and can be queried by any member of the program committee. That they can say, hey, has Charlie Catlett submitted his lightning talk yet? Or how many people from UC San Diego have submitted talks? Or is there a BOF submission yet for the SAGE project? So there are those kind of things that this second agent can answer for the program committee. Even more recently, I was working with Rick Stevens, and he put together an OpenClaw system with 4 kind of research claws. I think that's what they're called, agents. He put together 4 of them. All of them were powered by Claude Opus. All of mine are Claude Sonnet 4.6 for the smarter ones, and then for that do like Gmail and oversight. But then the general processing one is just running on a Quen model here on this. So what Rick did just last night was he was interested in understanding the latest of what's happening with benchmarking large language models in terms of agentic systems. And so he asked his four claws to go out while he was sleeping and do a bunch of research. And in the morning, he came back and he had this like 10-page paper that was put together by one of his agents, and then he sent it around. It's actually a pretty decent paper. So just another example of using these agentic systems that are I won't say, well, they're sort of like OpenClaw, sort of out of the box, but I'll also say that in the month that I've been putting the system together, I've had to do a lot of sort of scaffolding. And I'm putting a tutorial together on this. But I would just say a couple of lessons learned here. Number one, um, just thinking about safety and confinement, I thought a lot about the architecture and using sandboxes and Docker containers to limit what agents can do. I probably went a little bit overboard, but in my own home automation system a few weeks ago, I was lazy and had left an open port to the internet. And it didn't take but a few days for somebody to come into my system and put a bunch of prompt injection stuff. And it took me 6 hours to recover from that. There are no more open ports. I do Tailscale everywhere now, but I didn't want to deal with that with open cloud, and it was kind of an unknown to me. So a lot of safety and containment. I also found that agents don't have really a sense of time. They do have a what's called a heartbeat file, a heartbeat that tells them they look at it every 15 minutes and it tells them what to do, but it doesn't have a sort of a good way for the models to know that, every Monday at 4 in the morning, I want you to do this, like a calendar entry. Nor if I say, hey, in 4 hours, remind me to do this. The agents don't really have a good way of saying, okay, I'll do that in 4 hours. And so I give them a to-do list. And there are other things, configuration management. A big one, which is sort of a philosophical architecture one about agentic systems, or at least about systems like OpenClaw, is that I found that even smart models, even like Claude Sonnet 4.6, sometimes just do a really poor job at very simple procedural things like um, take this row out of this spreadsheet and append it to this spreadsheet over here. And so I came up with a sort of set of scaffolding that would have run books for things that are procedural, deterministic, that you really don't need a reasoning model to do. And with those are scripts that just go out and do these things. So effectively, what I've done is made a way for these agents to use ad hoc tools that I need for the tasks that I need. And then the last one here, that's the separation of duties. And the last one here is this layered oversight. Again, overly paranoid because this is sort of was a new system to me. And so anytime an email goes out, it's restricted by having to go only to people in a Google Contacts list for the conference, for example. And there's a smart agent that oversees and looks and approves every message that goes out to make sure we're not spamming anyone, or the agent doesn't come up with something crazy inappropriate. So anyway, so that's a kind of a new area. It seems to be all the rage these days, and an example of agentic systems. So let me pause right there, and then I'll go into talking about the International Trillion Parameter Consortium. So again, I don't know how to see the chat, but if you have a question, go ahead and turn your camera on or wave or something. All right, so I'm gonna keep pushing through here, and then we'll have time at the end. So I mentioned earlier that we had done these workshops with DOE labs, and they weren't just DOE labs. It was DOE labs, it was industry, it was academia, and these workshops in 2019 and then in 2022, there were typically 350 to 400 people. And so we had this community that when we published the last report from the workshops in June of 2023, we kind of looked at each other and were like, well, we have momentum. We have a community of like 1,000, 1,500 people. So how do we keep this momentum going? And we decided to propose a new consortium. And so there were a number of organizations, Argonne, Oak Ridge National Lab, RIKEN in Japan, AIST in Japan, Barcelona Supercomputer Center, CSC, Finland, all that said, yeah, let's put something together that's international and that can give this community a place to continue working together. So we formed this Trillion Parameter Consortium in August of 2023, and we have a number of things that are sort of ongoing. You can see in the upper right, there's this biweekly seminar series. The median attendance to that is about 35 people. The most we've ever had is about 105, and the fewest we've had is about a dozen. So it seems to be fairly well attended. And then you can see in the middle bottom here, I think that's 13 or 14 events that we have done over the last 3 years so starting in the bottom left of that slide under TPC events is that August of 2023. And so you can see there are one, two, three, four, five, six green boxes there, which are peer-reviewed workshops at large-scale conferences. What's not shown there, I don't think. Yeah, 2026 is not shown. We've already done two more meetings, two more workshops. One that's already happened in January this year at Supercomputing Asia, a major 2-day workshop, and another one that's going to happen in ISC in May or June. And then we've been accepted to do a peer-reviewed workshop, the third workshop at Supercomputing 26. And then there's one, two, three, four quarterly hackathons. We also do hackathons at those red boxes, which are all hands conferences. And those are typically 30 to 70 people that come together and work together on anywhere from 4 to 6 projects. And they work for 3 days together and push through. Some of those groups tend to meet at all of the hackathons. They're all open to new participants, but one, for example, that has met at every hackathon for the last year and will meet. The next one is mid-April in Bologna. It's hosted by Cineca, which is the Italian Supercomputing Center. So that one and all the ones of last year, there's a group that's built an agentic co-scientist for life sciences. And that group will come together in Bologna with a companion group down in New Zealand that will kind of work together in the afternoon there and in the morning in Bologna. And then the three so far all hands meetings, we had 180 in 2024. We doubled to 360 last year. We think we may double again this year, and I've got some more information about that. So, and then lastly on this slide, we do have a Slack workspace with 17 or 1800 people in it. We find the community tends to be, some work in Slack, some don't. A lot of email, but there is at least some coordination that's happening in Slack. And there's also, it seems that there is probably half the activity in Slack happens in direct messages where people just form an ad hoc group. We don't know what they're saying, but we get stats from Slack that says how many messages are of different kinds. We just don't know who's in those DMs or what's being said if we're not part of them. But I thought that was an interesting distribution. We have over 90 organizations have joined TPC, and this is something that is evolving right now. All of them, there's no cost to joining TPC. We encourage anyone to that's involved to bring their organization in so that we have this sort of meeting of the minds in the form of a non-legal collaborative letter of collaboration that just says, yeah, we agree with these 3 goals of TPC: building an open community, incubating and launching projects, and creating a global network of resources and expertise. And we're committed to these principles of transparency and privacy and trustworthiness, et cetera. So over 90 organizations have signed that. And then more recently, we've grown to the point where the Secretariat, which has been it's been me with a bunch of staff support from Argonne and a bunch of collaborators, of course, on steering groups and planning teams. But we've decided that we need to make that Secretariat an actual separately funded and deliberately funded with staff members. And so we've started an industry sponsorship program, and we've got let's see, I guess there are a dozen or so sponsors that have already signed up. to help with the Secretariat. And for that, we have been working with Tabor Communications for the last 2 years. You may know them from HPC Wire, AI Wire. They do major conferences and of course, media with those kind of reports. Anyway, you can see the organizations are spread across the world with, I don't know how many countries on the right, but all three regions of the Americas, Asia Pacific, and EMEA. And so apart from activities, uh, what has happened with TBC is there are working groups, and those working groups are affinity groups around things like a model architecture and training performance. But we decided after a sort of brainstorm with about 30 leaders from around the world last summer, we decided to focus around a half dozen, actually um, seven collaborative initiatives that we would try to steer people toward as a way to more precisely find collaborators. One that was added last summer that wasn't really something we had thought about before was that there were an increasing number of HPC centers, and this is the lower right, lower left there, that were offering inference services. And so there was demand for a working group that were HPC providers, centers that were trying to adjust their centers to adapt to new workloads that people doing AI would need for data movement, certainly for inferencing services. And so that became one of the initiatives. They're all loosely described on the web. We did at the closing of last year's all hands meeting, we did a live survey, and we found I think there were maybe 100 people that were there still at the end of the meeting, and more than two-thirds of them said, I'm interested in being involved in this effort, 1 through 7, one of those efforts, and I'm even willing to bring people and students. So there is a pent up, I would say, energy in the community to work together. And we view these and TPC generally as a place where we can catalyze that energy into productive collaborations. I mentioned the spring hackathon just to give you an idea of the teams that are meeting. You can see them listed at the bottom. There's one that's looking at MCP architectures, one that's looking at reinforcement learning and reasoning, another one at agentic systems. This is the co-scientist project that I mentioned that started last March and has been going every hackathon since. And then some of us are exploring the notion of a sort of LLM swarm architecture, where you have thousands of agents and you're trying to orchestrate their collaboration, like maybe an open claw, but on at a scale of 1,000 times what I might run on my own open claw system. So let me close by just telling you, you really should consider joining us in Baltimore, May 31st through June 3rd. We have just once a year these all hands conferences. We expect 500 to 700 people, and the way the conference is laid out is all day Sunday are hackathons and Monday morning, and then Sunday afternoon and Monday morning are multiple tutorials. We're up to 6 tutorials now, and we'll probably be up to 8 by the end of the month. And then we have a series of plenary sessions with keynotes and invited speakers. And then these 8-way breakouts, which loosely map to those initiatives that I was just telling you about. So the plenaries look like this. Most plenaries have 2 or 3 speakers, and these are the ones that we have already agreed and coming and scheduled to go. The main keynotes are Dario Gil from Department of Energy. He's responsible for the Genesis mission. He's the Undersecretary for Science. And then we have another main keynote from Noah Smith from AI2 and the University of Washington. Noah is the PI for this $152 million effort NSF and NVIDIA are funding to build open frontier scale models. And other keynotes, Rick Stevens, Katie Antipas, who runs the NAIR program for NSF, and you can see other speakers there as well. We also have a session that Karthik Durasamy from University of Michigan is leading, where we have four students that each will present, PhD students that each will present award-winning papers from other conferences, ICML, NeurIPS, and I think there were, let's say there was one from SC25, and I don't remember what the fourth one was from. So a plenary just dedicated to students. I'll say one more thing. I keep going back. So one more thing is with this conference, we are also doing a companion meeting in Munich because there are a lot of people that don't have the funding to travel internationally but want to be involved, especially from Europe. And so the in Munich on Tuesday in the morning there, they will watch the recorded plenaries from the day before, and then they will join us morning for us in Baltimore, after lunch for them in Munich, for these joint plenaries in the on Tuesday, where we have speakers in Munich as in Baltimore. So we expect 500 to 700 people in Baltimore, and we're thinking in the range we probably will see in the range of 100 people that will be in Munich at LRZ. Okay, and then these are the 8 breakout tracks, and they roughly align with the major initiatives that I just mentioned. And so to get involved, you should of course register, but also you can do a couple of things. One, you can propose the parallel tracks. These are what you're seeing there are 40 90-minute slots, 8-way parallel times 5. Each of those 90-minute slots, and sometimes multiple of them, will be working groups that organize, and they do maybe 4 or 5 lightning talks, and then that's an hour, and then half an hour for discussion looking for collaborations. Some of those parallel breakout slots are birds of a feather session. You might have an AI institute or a multi-institutional project, and you want to sort of present it to the TPC community and try to find collaborators. Then there's a link that you can propose a BOF for your effort, and bring in your lightning speakers from your project, and use the 90 minutes session that way. The other opportunity you have, whether you do a BOF or not, is to propose a lightning talk. These are 10 to 12-minute talks. They're not meant to be finalized papers, although they certainly could be. And what they're really meant is for you to be able to give an update to your peers in a particular area of AI-related science about what you're learning and what you're doing, and even engage them for ideas. So I say those don't need to be talks, but we have a solicitation we'll be opening up for papers to be submitted to a peer-reviewed workshop at Supercomputing 26. And so we've told people who are giving lightning talks, hey, you should also put together a 5-page paper. Our papers for SC25 for our workshop are limited to 5 pages plus an appendix. And so we're encouraging people to take their lightning talks and then turn them into, they'll have a couple of, maybe a month afterward, a little over a month after TPC 26, to put them into a 5-page paper for publication as part of the proceedings of Supercomputing 26. All right, so I'm going to stop there. There's a QR code if you want to grab it. It'll take you to the TPC site, and I'll give you a few seconds to do that, to scramble for your cameras, and then I'll go ahead and stop. And if you didn't get it, it's tpc26.org, and that has all the information about the conference. And tpc.dev, tpc.dev is the TPC website. Well, thank you. I can now see all the names and a few of the faces, and I'd be happy to take any questions. I'll go ahead and read this question. I'm a software engineer involved in this AI world. Wanted to say thank you. Let's see. How will success be measured for these collaborative projects? So I think you're probably maybe talking about the TPC collaborative projects. There are a couple of ways that we would gauge success. I think that the biggest one is that the participants in these collaborative projects would be able to say, this has accelerated my efforts. And I think that where you have collaborative projects that don't do that, they don't really survive. So I think that in some sense, collaborations that take off and have some sustainability over time are signs of success. The agentic co-scientists for life sciences, the fact that, so what happened was at the hackathon in Kobe in March last year, so just a year ago, they were going to work on some things together. They was people from Argonne and Barcelona Supercomputer Center and Riken in Kobe. And they had this agenda of things they wanted to work on together. But Google came out with the co-scientist paper like 2 weeks before. So they got together in Kobe. They're like, hey, that sounds really cool. Let's see if we could replicate what Google did. So they spent those 3 days getting something sort of rough up and going. And then today, 13 months later, they're still working on that and perfecting it, have been using it in their science, and will be getting together again in a couple of weeks in Bologna.
Thank you very much, Charlie. This is Sajida, and that was my question. You explained it very well. Um, my next question is related to same. What kind of real world application or outcomes do you expect from these kind of prototypes?
You're talking about the SAGE project?
Yes.
Yeah. So the project now, SAGE project, I showed you the map of Chicago. Most of the nodes are out in wilderness areas, and they are placed there and designed because every set of nodes can be some unique set of sensors. I think at this point there are in the range of 24 science projects. It's one of the reasons why NSF supported this effort as a 5-year, $25 million award as part of the NAIR pilot. There are a couple dozen science projects out there just in the NSF community. There are about a dozen in the DOE community where groups of scientists have said, we need this many nodes, we need them to do this, and we're using them for our science. A really good example, I would say, is there's a project that's run out of UCSD that uses cameras, and they have cameras all around Southern California on towers to try to detect and track wildfires. They've been one of our collaborators working with some of our postdocs to get the machine learning algorithms, the AI models to be well trained to differentiate between the cloud on the horizon and a wildfire. There's another group in Hawaii, in Lahaina, where I showed those. There was a couple of nodes there, and that group is also looking at because of the wildfire disaster that happened there. And there's also wildfire work at the Oregon Hazards Lab at the University of Oregon. So those are sort of examples. There's a particular, maybe it's two different tribes of Native Americans in Wisconsin who are using nodes to monitor wetlands. There are projects in Chicago that are using nodes to be able to detect street flooding. So the SAGE project is really has become an infrastructure rather than a research project itself, although it's definitely research in terms of the computer science. So anyway, I hope that helps to answer your question.
Yes, sir. Thank you very much.
All right, if there are no additional questions, we'd like to thank everyone, especially Charlie. Thank you very much for a great presentation this month. And we will be back next month for our monthly webinar series. Thanks again, Charlie. We appreciate it.
All right. Thanks, everyone.